Hello guys, today we are going to start to write a code with relation of the solver design in the engineering perspectives. In order to do that, we should utilize the C programming language, and so as well as the Visual Studio 2019. And so as all we do, we need to create a new project file in here. And so we need to select the C++ compiler with the empty project selection. We push the next button in here, and so we should select the directory in here. In this lesson I use this current folder in here, and you may choose the different path location. And so I always picked the place solution and project in the same directory. Okay, this should be checked. And so the project name is the week 8. Okay, and so in order to create this project, we should push this button in here, and then the project file is created. Okay, and so as always, we have the header files, resource file and source file in here, but we don't have any knowledge about the header file or source file, and so I created this library in the source file. Okay, and so I need to add this location in here as a new item, and in order to create a C programming compiler, and so we need to add this file main.c extension. Okay, and so this is our program in here. In order to try to code, I need to give the simple example code in here. If the compiler and debugger is okay in this notation, and so printf hello. Okay, and so if I run this program and then I obtained this debug console screen. Okay, and so what about our lesson? Our lesson directly relates to the solver design. And so what does that mean? The solver design is a title in here, and so I need to comment also these things in order to create a section to code everything related to the solver design. Okay, and so in order to give the explanation related to this code, and so the first question is that what is the solver? Generally in the engineering approach, we have an equation like this one. Y is equal to what? A times x plus b. Okay, and so in order to find the x value in here, and then you should write the b is taking into the left hand side as a minus term, and so divided by a gives us what? The solution of these things. X is equal to 1 divided by a times what? Y minus b. Okay, this is our solution. But in the engineering approach, there is everything related to the solver is not easy, because the equation has time dependent, or in some sense or variable dependent. In the math class, you should see that because the y is equal to the what? F is a function of x, and so if we know the x value, and so we can generate the y or y value in here. But what about this? If we have this kind of equation, y dot means that the derivative of y with respect to time. Okay, this is our problem, and so in some equations we should use this notation. Y dot or x dot is equal to the what? Example, x dot A times X plus B times U. Especially in the mechatronic engineering, we should use this equation as a linear system state space design, okay? Because we need to solve it, but the X is the variant of, or the dependent of the time, and so U is also dependent on the time. Especially in the system dynamics or control theory, we should utilize this equation or like form of this equation, okay? The similar form of these things is used in extensively in the system dynamics and control approach in mechatronic engineering, okay? But these are first example in here, and so we need to learn how to we obtain the solution value by using this equation form, okay? This is our general main approach of this lesson, okay? And so what about this? How can we solve this equation in the real life or physical systems? Anything in the nature, like the car or ball or falling ball. And so you should remember that in the physics you can calculate how many times required for a falling ball to the ground, okay? And so the everything in the universe is considered as a physical systems, okay? But these systems may be time dependent, and actually in the real life or in the nature everything is time dependent, okay? And so we should utilize these things with the base of the sampling period, okay? In the real life, the sampling period is equal to the 0 or goes to the 0, comes from the limit theorem, okay? But in the mechatronic engineering or in the solving this equation, we require to some machines or computers in order to create this. But in the computer structure or microprocessors, we have a specific sampling period, and this sampling period does not equal to the 0 or going to the 0, okay? Because everything in the electronics has this kind of information, and so in the physical system structure we have the continuous form of this equation, okay? And so the dt or the sampling period is going to what? To 0, and then we can create any dynamics in here. But in the solving process we should utilize the computer or microprocessor or any software, and so these softwares or computers or microprocessors, especially in the, maybe you should know these things, the Arduino or STM or ARM microprocessor, we should utilize this sampling period notation. And so if we have this kind of information in here, and then we should utilize the discrete theory in here, okay? And so you don't be afraid of anything in this notation, because you shouldn't know everything related to this form of equations or the topics, but the discrete theory gives us a unique way to solve the physical system in the continuous form as a discrete one, or with the sampling period usage, okay? And so how can we solve this kind of equation. The main problem is, in this class, the x dot is equal to the what? Ix plus b times u. Okay, and so firstly we need to discretize the whole equation. Okay, like this one. X dot can be discretized or the iterate with the usage of the forward difference equation. Okay, for difference equation gives us x dot is equal to the what? Equal to the sampling period times x k plus 1 minus x k. Okay, and so this is the forward equation or the notation in here. And so x k is the now value or present value. And so if we have this equation form in here, and then we should also have this value, and so the specific sampling period gives us the x dot value in time. Okay, and so what about our equation? Our equation is that x dot is equal to the what? A times x plus b times u. Okay, and so I can write this equation in here: x k plus 1 x k. This is the present value, this is the forward value in here, and so divided by dt is equal to what? A times x k plus b times u k, because the u and x is dependent on the time or the function of the time. Okay, and so if we know the sampling period in here, and so we can interpret this equation as in the form of this one, in the discrete one. Okay, and so how can we reorganize this equation form in order to process in the C programming language? You should remember that the x k plus 1 is equal to the what? Is equal to this term, and so the x k plus 1 should be generated by the programming language or the codes. Okay, because the k are the present value, or we have this kind of values in the program. And so if we calculate these things in here, like this one, the x k plus dt times a times x k plus b times uk in here, and so if we have the uk and xk value for a given a and b parameters, and so we can calculate the xk plus 1 value. And how can we use this information? Suppose that the x0 is given to us as a 1 value in here, and u0 is 2 value. Okay, a 1 b 1. Okay, and so in the first iteration we should use this calculation, and so x0 is in here, xk plus 1, x1 is equal to what? 0 plus 1, and so this is equal to the x0 plus dt times a is equal to the 1 times x0 plus b is equal to the 1 times u0. Okay, these are general notation, and so the dt is equal to the what? 0.01, and so we can replace it this value with this one. Okay, and so in conclusion we can calculate this phenomenon by using iteration techniques, because the x and u are given to us, and so we can calculate x1 value. And so what about the next iteration? The next iteration, if the k value is equal to the 1, and so 1 plus 1 is equal to the what? x1 times 0 dot 0 1 times 1 times x1 plus 1 times u1. Okay, and so how can we calculate these things? In the first place, we obtain this equation as a form of the x1 is equal to the what? These things. And so this equation can be interpreted by like this one is equal to the what? This equation x2 is equal to the x1 comes from these things because this value is included in here, and so plus 0.01 times 1 times these things plus 1 times u1. And so it looks like the very complex, but in the programming language it's easy to solve this equation, because if we have the whole variable in the programming notation, and so we can easily solve this equation. And so in this lesson we will try to create this form of equation in order to solve the time dependent function or the time derivative or the integral function of this form. And so this is the general method in here, and so you are using this approach in the system dynamics and control theory in mechatronic engineering, or in the any process in the mathematical solutions. Okay, and so if we have the whole knowledge about the codes in here, and then we can build the main function blocks at this position. The forward solver design, the name should be changed because the method which we are using in here is the forward difference equation, and so we have also another two solver design, the backward and the centered. Okay, but in this lesson we will use the forward solver design techniques. Okay, and so in order to create in order to use some specific general function, we should include the standard input output dot header file in here by using these codes. Okay, and so we need to add the main start address in here with the return value of 0. 0 means the success value of the main function, and so every code should be written in these notations. Okay, these are the main general code, and so we can start to write the specific variables and the notation in here. Okay, and so firstly we need to define the variables that we are using the system or the main function block. Okay, and so the definition of the system means that the car or falling ball, but in math we should describe these physical systems by the equation, or in physics the equation of motion. Okay, and so we should describe the whole variables in here, variable definition. Okay, and so what about the R parameters in here, the A and B? Okay, and so int A is equal to the 1, int B is equal to the 1, and so you should remember that the whole equation may give us the floating value. And what about this? The floating value means that the 0.01, and so the integer only stores the integer value in the maths. Okay, and so you should notice that precaution of these things, the double should be used in this notation. Okay, because your number is equal to the what is equal to the 1.1, or maybe 1.1 or 0.1. And so integer cannot store this variable. Integer sees only these things, okay? And so you may lose the information from the code, and you should warn about that, okay? And so these are 1.1 parameters in here, and so we also have x value with the type of double x present, okay? And so the x present value is initialized by the 0.0, okay? And so what about this? The xk plus 1 is also another variable in our code. It's the double x forward, okay? And so it may also be initialized by the 0.0, okay, in the double term. And we need also define the double sampling period in here, or dt may be used as a name in here, but in the expansion form we should describe the sampling period in here. In generally, in the microprocessor or the computers, 0.001 or the 1 milliseconds can be selected as a sampling period, okay? And so how can we okay, the input variable also should be defined in here, u present value, okay, 0.0. And so what about our algorithm? Our algorithm increase in the iteration, and so we need to use what? To for or while equation in here. And so iteration variable or loop should be defined in here, okay? And so in order to write this equation, we need to create a for loop in here. Integer I is equal to the 0, and so E goes to the what? To final position. Okay, and so we need to give the time conditions or time limits in here. In the time limits, we should define the t initial value, okay, as a 0.0. And so in the iteration variable, t final value should also be given in here, like 5 seconds. And so this code solves the equation with respect to the time with the range of what? T initial value 0.0 to t final value 5.0. And so 0 seconds to 5 seconds is calculated in this code. And so we need to create the length of solver in here, I++. But how can we calculate these things? These things calculated with the notation of what? Length or integer value should be defined in here, because the for loop is also given to the integer value. And so length of solver should be equal to the what? The total time period, t final value minus t initial value, divided by what? Divided by the sampling period, because our algorithm should be written or should be run on this calculation. And so the each iteration is equal to the sampling period. And so this sampling period is equal to these things, and then the final value minus t initial value is the total elapsed time on our algorithm. And so if we divide it by the sampling period, and so we need to create the number of the length of solver in this code. And so the total history is given with the range of this value. Okay? And so you will use this length of solver or these codes on the microprocessor to solve any system dynamics model or any physical system in order to simulate every response on the coding techniques. Okay? And so this important value. Okay? And so we need to use detailed mathematical notation in here as an engineer, because the engineer solves the problem with the aid of the mathematics, physics, and the modeling techniques. Okay? And so the iteration variable or loop is done in here, and then our equation is that. And so the x k plus 1 is also given in here. X k plus 1 is equal to the what? X forward value. Okay? And so the x forward is equal to the what? X present value. Plus dt is equal to the what? The sampling period. Okay? Times what? The a is defined in the beginning of this code times x present, because the xk times a is given here, and so plus b times u present. Okay? This is our general solver code related to what? To forward difference equation. And so if we have this kind of equation or system parameters with respect to the time or dependent of the time, and so we can obtain the forward variable and present variable in like this one. Okay? But there are main problem in here. The main problem is that in each iteration the indice of x is increased, and so in the next iteration we should use the x1 value. Okay, x1 is equal to the what? Is equal to the x present is equal to the x forward in this notation, because we need to update the variable or system variable in here. Right? And then in the next loop the x present is equal to the x forward, or x0 gives us the x1 and x1 is equal to the x present, and so the for loop is going to do restart, and so x present is equal to the x1, and then we can calculate the x2 value by using the x present value. Okay? And so how can we display whole variable or system results? Okay, we can use the printf function in here. The printf function can be used to show the every variable in this notation. Okay, and so the time value is equal to the use %lf, and so the x value is equal to the what? Is equal to the %lf, because every variable is in the type of the double, and so in the printf function we should use this notation. Okay, and so we need to also give the input variable in here, %lf value. And so what about this? The time value is equal to the what? Is equal to the sampling period times I, because in each iteration if the e is increased, and so the sampling period should be add on this time period in here. and then the x value is equal to the what? X present. Okay, and so the input value u present. U present. Okay, and so in order to change the u present value, which is the in the first place u value in here, and so we need to give some code in here, u present value. Update can be accomplished by using these codes. U present it each time is equal to the what is equal to the 1. Okay, and so if we are run on this code and then the time value is increased like this one. This is the general history of this equation. Time is increased with the sampling period. At each process, x is equal to the what in each process is changed, but always increasing. In the mechatronic engineering, this is unstable. You don't need to learn this phenomena, but if I am choosing this final value as a 500, and so x goes to the what is goes to the infinity. Okay, is always increasing like this one, and so these are general elimination or the general solution of our algorithm. Okay, but in the real life, if you are choosing to a and b parameter with the proper of the real life application, and so the result of your equation like this one. Okay, and so how can we stable this system or this equation in order to go to some specific variables? If I set the a value is equal to the a is equal to the -1, and so if I run this program and then the x is going to 1 value, and so what's the importance of these things? The importance of these things is that we can say now the system is going to always to 1 value. Okay, and so in the real life application, we should create a system and we should design a model with the mechanical parts or electronical parts, but in the software design we can utilize like these solver techniques in order to simulate the whole system without the cost. Okay, and so we can have or we may have the prediction of our system, like the car, like the plane, like the rocket, okay, in the computer software. And so this code the basis of the simulation programs. Okay, because the simulation programs dependent of the time or with respect to the time, and so we need to iterate all the things like the physical one. And so this code gives us a way to create this simulation program. But not only the simulation things, in the neural networks or deep learning approach, you should also solve the equations in order to obtain the inverse value or determinant value or the time dependent function. Okay, and so the whole things in the general notation, which means that for example the control theory or system dynamics or the deep learning or neural network or machine learning, you should utilize these codes in order to obtain the time response of your system. Okay, this is the basic code of this things. Okay, and so how can we obtain or create the function block in order to use this forward difference equation by using only calling a one function. And so we can create the function prototype in here. Void forward difference equation can be given in here, and so we need to take some parameters in here, like the one a, or forward first integer first param or parameter, or integer second parameter, or like this value, x present value, double x present value, or we should not add these things, but we should add the double sampling period value as a prototype. And so if I'm this code in here, and then we can use these techniques like this one. We can copy of all these things as another example in here. Solver design with function body. We can create the function blocks in here like this one. Okay, and so in this notation we may delete the whole code, and so the forward difference equation can be called in here like this one. First parameter is equal to the a, second parameter is equal to the b, and the sampling period is equal to the what? The sampling periods. Okay, and so if I'm right, the whole these values is equal to the what? Is equal to the system parameters. Okay, and so in the first place we should give another function in here like this one. The void display function can be defined in here in the display notation. Time and x present and u present should be given to the system, and so double time, double x present, and double x u present should be given to these codes. Okay, and so we should also call these function blocks in here like this one. Okay, and time parameter, x present parameter, and the u present. Okay, and so if I'm right, the forward difference equation can be called and display function can be called and generates the previous results in our console debug section. But the forward difference equation should be initialized by the t initial value or t final value in here, and so we should also give the t initial value and t final value. Okay, because our algorithm run with these parameters. Okay, and we should also give, or we should obtain the function body in here like this one. We should obtain the x present and x forward value. If this is the forward difference equation, and so the x forward should be returned and the x present should be given to this equation, and this is the general standard notation of the creation of the function body. Okay, and so we need to change the declaration of the forward difference equation like this one. The double x present value in here, and so the a b is in here, t initial value like this one, double t initial value and double t final value. Okay, in this notation. But if we are using the for loop design in here, and so we just give the system as a time variable, okay? But in this notation we should also delete this form of for expression in here. This is not easy, I know, but the professional codes is written like this one, okay? And the forward difference equation at each time returns the x forward value, okay? And so what about this? The total forward difference equation is designed by using these parameters like this one. This is our general function definition blocks in here. And so in the first place we should create the for value in here. Integer I is equal to what? Is equal to 0. I is a length of what? Solver. But this solver should be calculated in the forward difference equation, okay? I plus plus. And so the length of solver should be calculated by what? T initial value T final value minus what? The divided by the sampling periods in here, okay? Because the programmer gives us the sampling period, T initial value and T final value, okay? And so the solver design should be initialized by the double x present value, or in some sense the x0 in this notation. And so this can be converted by the x0 value, because every equation needs the initial values, okay? And so the x0 is defined by what? The x0 is defined by 1.0 or 0.0, okay? Double x0 is in here, and so the x present and x forward is not used in our algorithms, okay? Because the forward difference equation is created these forms, okay? And so what about the solver design? x0 is in here, and so the internal double x present value should be initialized by the x0, and double x forward value is equal to 0.0. And so we need to use the every parameters in here, but the u presents should also be given to these function blocks in here, u present, and so we should change the declaration of these things, u present, okay? And so if we are using these formats, the x forward value is equal to what? X present value plus what? Plus these things, like this one, okay? Because the x forward is defined in here, x present with the initialization of the x0 is given in here, and a is equal to the first param, and b is equal to the second param, okay? This is our general solution. And so in each iteration, x present value is equal to the what? X forward value. Update the variable, okay? And so if you are using this notation in here and display function body is removed at this position, and so okay, if you run this program and then we have an error, and so if you run this program and there is no error, and so the forward difference equation is solves the whole this parameter. Okay, but how can we display this whole equation? And so we have a display function in here. The time parameter is equal to the what is equal to the I times sampling period, and x present and u present is given in here. Okay, and so display function can be written like the display function with a parameter of the double time, and so double x present value and double u present value. And so in this function block printf can be used. Time percentage lf x value percentage lf, and so the u or input value percentage lf can be given. And so time is equal to what? Time, because it's a parameter, function parameter in here, and so the display function is fed by using the I times sampling period. And so the x value is equal to what? X present value, which is also a function parameter, and so the u present value can be showing by using the printf function. Okay, and so if I'm right and the code is okay, and so if we run these codes and then the function double to int double a, okay, first parameter type is wrong in here, and so we need to change the first param and second param with the type of the double, and so is also function or forward difference equation updated. Okay, like this one. And so we have also another variable in here initializing conversion from the double to int double. Okay, and so we need to cast these things in here because the length of solver integer value in here, and so if we run this program the display function is in here like this one. Okay, the declaration of the display function is not showing in our codes. Okay, and so if we run this program and then the x is going to the 1 and the time is increased. Okay, and so this is a simple form of equation like this one. The parameters should be defined in here, and so forward difference equation solves the system parameters. And if you are using any simulation program, Unity engine or Unreal engine or any neural networks or system dynamics model or MATLAB function, the forward difference equation is the basis of the solution techniques in that system design. Okay, especially in the C programming language. And so we can change the variable name in here like this one. We can copy off these things, and so all the code is commented. And so in the example notation we can use this display function and the code with these parameters. Okay, like this one. And so we can delete the whole these variables like this one. x0 is equal to what? 0.0, and so the first parameter -1 and so b is equal to the 2, and sampling period is equal to the what? 0.01, and initial value, for example, 1.0, and so the final value is 10 dot times, and present value, your present value, is equal to what? 5. And so if you run this program with the different parameters, and the code gives us the different solutions in here, the x is equal to the 0, and so the time variable is increased with this notation. But you should notice that the time is equal to 0, but we can give, or we have given to the system a one variable. Okay, the code should be updated with the parameter of t initial value plus I times sampling period, because the t initial value is equal to 1 in here. And so if I'm right, if we rerun this program, and then the 10 is the final value, and so the time is equal to the what? 1. And so the x0 should be initialized as a 5 value in here. And so if you run this program, and then this time variable solution is obtained with the initial value of time 1 second, x is equal to the 5, input 5. And so the system goes to what? Goes to the 10 value in here. And so if I'm right, the 100 is given to the final time, and so the input is 5, and the x is the 10 value. And so these are general notation to define the solver design in here. And so how can we use this for difference equation? In order to create a system, or in order to control a car, the automatic car, or the autonomous car, or the plane, or drone, and so you need to learn about how the system reacts in time. And so this simulation program clearly explains that the x value, for example the position or the distance value from the ground, should be calculated by using this program. And so this is a prediction value of our system, and so we can design as an engineer a system by using these parameters. Okay, and so in the mechatronic engineering we should utilize this kind of function block, because in the Arduino or any microprocessors, STM or ARM processors, we should use the C language. Okay, or in the game theory, or the game developer should utilize this kind of equation for difference equation, or the any time responsive equation, in order to create a game zone, a physical games. Okay, like the Angry Birds. And so these are the final of this lesson. I hope you enjoy it and you learn about how can we use the solver design or create the solver design by using the C programming language. And so if you're any further question, you can mail me about these things. And so have a good day.